Biscuits. Okay. Maybe, or I don't know if I streamed on the correct one. I did. Fantastic. Oh, okay. Well, hello everyone. Hello. Apologies for the late stream. I got yeah, I don't know. I decided to take like a little bit of break and forgot to change the schedule. Okay. Nonetheless, today will be a kind of a long stream, I think. Yeah, at least. Do not disturb. What is it? 4 p.m. now. So maybe 6-hour stream, something like that. Just fairly excited. I'm gonna do mostly focus on ODE, I think, and then I'll maybe switch to linear analysis or statistics. Yeah, that's probably what I'll do. Hello Smoothhacker, welcome. Welcome. Hello James Grind as well. Man, drinking like hot water is so nice. I just made like boiled some water and I just put it in a thermos, and it's actually one of the nicest things to drink when it's warm. I have a midterm presentation tomorrow and I need to lock in. Alright, good luck with that. Also need to lock in. I mean, I didn't have the time to answer all the questions this morning. Yeah, there were 12 of these questions or problems. I think I got yeah, up to 3.6, and then I had lunch with a friend, which yeah. So I want to continue and do all the other 10 problems. Love the title of the video, indeed. I mean, I guess, yeah. Try something new. Cool. Alright, I think I'll boil some more water, and then I'll just continue after that with the problems. There were some that I couldn't really get. I mean, for example, 3.6, or no, that's the one I'm doing. Never mind. I wrote. I don't know why I did that. Yeah, so for this 3.5, I think I skipped it. Yeah, since I didn't know what a quadratic matrix was, I skipped it, and then I asked ChatGPT and skipped it. But I think, yeah, I'll do this one. Still haven't done it. Yeah, 34 as well. I can really figure out. And then 33, I think, was fine. Yeah, that I've done. And then 32, I've also done after a lot of computation. But yeah, these ones are possible. But yeah, then these other ones were not really that smooth. Alright, I'll be right back. I'll boil some water. Alright, whilst that is boiling, I'll just continue here, I guess. This one is just, I want to do some other exercises before doing this. And then for 35, yes, what is a quadratic matrix? Maybe I'll just search it up here. Quadratic matrix? Or is it just like a quadratic? Oh no, that's a bilinear form. Right, so it's, I don't think it's like a, I was thinking like a bilinear form, but what is the definition of that? Man, my linear algebra is rusty. Quadratic matrix. Is a square matrix that is used to represent a quadratic form. Oh yeah, it is a quadratic form. Yes. Wait, what was the bilinear form? Yes, I remember this. These are vector variables. Right, so we know that A is of the form X transpose and then some symmetric D, or maybe I'll call it a B, then X, like that. And we have that B is symmetric. Alright. This is what we have. Okay, I tried to do some computation, but it didn't really go that well for me. All right. Okay, so we need to take the derivative of the cosine. All right. So that means that there exist these guys. These vector variables. All right, yeah, my bad. So A is the matrix inside the quadratic form. So there exists a quadratic form x of t like this. I'm pretty sure. All right. Question is how to use this. How to use this. Okay. Symmetric and is that real? That's also math student. Welcome, Shadow. What do you specifically study now? Like right now I'm doing ODE. But yeah. Not really sure where to even start. I mean, I wanted to like just write out the definition of cos of TA, but seems to be a not that fruitful method. I guess also like when is this series, like the Taylor expansion uniformly convergent? Like what is the radius of convergence for what is radius of cos of like t of Do I remember the theorems? So was the radius of convergence equal to 1 over the lim sup of the Here's the part. Wait, let me open up a book on this. I had a good book. Yeah, let me see. On this. There we go. Maybe I'll just download it. On series. Here's this radius of convergence. Okay, let's see. Right. Okay, so I guess like I'm not entirely sure the methodology. I mean, we could use the M test to, compare it to something. Mayhaps. Of CK1 over K. As K goes to infinity. Hello Vanessa, a neuro major, there's math here too. Indeed. If I factorials k factorial in the coefficients, therefore it is useful to know that we can escape math, it is everywhere. Yeah. I mean, it's also kind of an, like, if you get used to it, it's like a nice thing, you know. Which says 8.7. Anyways, so here we have let me look. Let's see, k is equal to 1 minus k divided by 2k plus 1. I'm not really sure that, I mean, maybe it's like all, like, the radius convergence is like infinity. I'm not really sure. I know for E it's infinity. Which is probably good thing to check as well. I mean, to be fair, I haven't really done this. That I guess I've just kind of ignore actually doing it myself, which is not really a good thing. So I think that's it. I mean, what's kind of interesting, I guess, is like here we have a power series, we have k, but we don't have it there. I mean, I guess it doesn't matter per se. Right, so this is the Hadamard formula. Right, so I mean, the absolute value of this is just equal to 1 over 2k plus 1, and this is always positive, so and then 1 over this 1 over k is that, and this is equal to 2k plus 1, like this. And alright, so we have factorial here as well. I think there was some exercise, right, showing that. So wait, no, this is wrong, sorry. Oopsies. Yeah, so we have the limit of this. And let me recall, like, if we have a sequence going like this, taking the lim sup is taking the largest value. So in this case, the lim sup would be equal to the limit, since it's an increasing function. If it's a decreasing function or sequence, the lim sup would always be equal to the first element, I think. And then the opposite for the lim inf would also be the first element, but if it's decreasing, would also always will be equal to the normal limit. Yeah, let me just recall this. So lim sup is equal, like if I have a sequence ak, it is equal to the limit as k goes to infinity of ak, where ak is the supremum of the set of all elements that are less than or equal to k. I mean, I guess you could write it like this, I think. Yeah, so the biggest element among the first k elements in the sequence. And then, right, so we'll begin with, for example, capital A1 would be just equal to A1, and A2 would be comparing A1 and A2. I guess taking the sub of this. This would be equal to A2, and A3 would be the sub of A1, A2, A3. Like this. And then, yeah, so in this case it serves, yeah, it's important to show that like if it's an increasing or decreasing function, I mean, based from this, I mean, we know that the limit as k goes to infinity of k factorial 1 over k is equal to infinity. So in this case we know that this is 0, which seems a bit weird. No, it's not weird at all. So taking 1 over ck, or the lim sup of, wait, let me think. So as this grows, this becomes smaller, right? So this is actually a decreasing function for sequence. And which implies that this is equal to the first element, or the last element, right? So the lim sup of this of ck 1 over k is equal to 0, or is rather equal to the limit, which is equal to 0. And this implies that r is equal to infinity. So in this case, it doesn't matter. Like this is, I guess this is important since in this problem we need to interchange the derivative and the sum, like infinite sum, which we can only do if it converges uniformly. And there's and the question was rather like, do we need to restrict t to be able to do this? And apparently not, since the radius converges infinity. So any so if you pick t to be any real number, it should be inside the like interior of the radius of convergence. Or is there a better way of saying this? Let's see, there was a theorem here. Maybe it's about right, so if it's around the Okay, so R is something less. Oh yes, of course. Yeah. Okay. Okay. So that was kind of like a tangent, but maybe it was a good tangent. And yeah. The thing is that I haven't really done these exercises. Maybe I should do them, honestly. Like the proof of the Hadamard's formula. I don't really know. Do I want to take this tangent? I think I will. So we have this formula. And let's see a proof of this. So the Hadamard's formula. So given a power series, we can say this is by the way, like you would say that y is entire if it can be written as like this, i.e. an entire function y. Then we have the radius of convergence is equal to this up here. Okay, so let's hear. So this is the limit, or we say L is this. So in the case where L is positive, 0, or diverges, I guess it can only be positive, right, since it's the absolute value here. We prove case 1, which is the most difficult. And we say this is equal to L. Okay. So basically what we need to show is that like the definition of radius convergence is that in this interval, like if let me see. Let's see. So if for all epsilon greater than 0, there exists, or like let's say x inside the interval x a minus r minus epsilon and a plus r plus epsilon. Series and diverges. Okay, this is just some nonsense, so maybe. False that for any epsilon greater than 0 there exists an n, so that when n is greater than this, this is less than is this a typo? Is this AK? Oh, yeah, this has to be a typo. It's CK, and then we have yeah. Latter expression converges when this is less than 1, which is the same as this. As this holds for every epsilon greater than 0, it follows that the power series converge absolutely when x minus a is less than 1 over L. We now prove that the power series diverges for all x, so that x minus a in this case there is some epsilon naught, so that in slim sub there exists infinitely many k, so that expression inside the parentheses will be larger than or equal to 1. From this it follows that the power series fails to the divergence test, and it diverges. Wait, let me grab the water, man. Okay, this is kind of like an interesting proof. I need some time to digest this proof. Okay, I actually want to spend like a lot of time on this, to be fair. Alrighty. Let's continue. Happy Wednesday. Hello e to the 2i pi. Man, these Twitch names, I mean, all like, I feel like most people who join from Twitch have the most mathy names. Which isn't a problem, of course. Let's see here. Okay. How is the analysis? It's going maybe not the best. I've gotten myself into like a bit of a tangent, but yeah. I want to figure out this proof for the Hadamard's formula, like for the radius of convergence, which you can see here. Which is a bit weird. I mean, we assume that L is like some constant, some finite positive real. Holds that for every epsilon there exists. I guess it's a little confusing. Alright, well, okay, I guess like if the lim sub exists, it implies that the limit exists. I think this was one of the theorems. Like, if the biggest value is always, like if you have some series like this, or maybe this is not the case. No, it's the other way around, right? Yeah, it's certainly not the case. So if the limit exists, implies that the lim sub exists. Yeah. But here. By the way, I think this is a typo with the A. I think it's just supposed to be CK, because A is not defined anywhere. Yeah, I don't really see how this is true though. It implies that C K absolute value over K epsilon. Sums 1 over 2 to the n x to the n converges whenever x is less than 2. Consecutive ratios between its factor 2 and the generalization of this is what the theorem is talking about. So if you wrote this, I mean, yeah, so like I'm guessing this text here is given from the definition of the lim sub, but I don't see how that is. Like, this is the definition of the limit of absolute value of ck to the 1 over k. But how is this? Oh wait, let me think. Right, I think it's that we can always bound it, right? So we have the limits up there, and for any ck right, this maybe goes to something here, and then this is the L, and then yeah, I think that makes sense. L is upper bound, yeah. Yes, it's not really saying that the limit exists, but rather that you can always bound it for any epsilon. Indeed. What does any of that symbol mean? Which symbol? Yeah. Yeah, so we have that when n is greater than n, it implies that 1 over k is less than or equal to L plus epsilon, and we can solve for ck, I guess. Okay. L plus E is an upper bound. Yeah, exactly. I mean, I mean, would L be an upper bound? I'm just thinking. I mean, if we have this, like, okay, so let's just make a series or a sequence. So let's say we have 1 minus 1 over n maybe. So So it starts at 0 and then grows to 1 when n is odd maybe, and when n is even we have 0. Certainly we would have that L is yeah, it would be an upper bound. So do we need epsilon? Maybe this is not the, or yeah, I mean yeah, this is not always the case. I mean, we can have a sequence that's just 1 here, and then it wouldn't be the upper bound. So I mean, in this case, yes, but yeah. I mean, I guess if it were just to be like this, then L wouldn't be an upper bound. Yeah. Sort of new to math, and I'm learning calc, so I can build a transformer, and I don't know any of that. Mean I'm on the most basic book in calc right now. No problem. We've all been there. Are you thinking of a transformer in a microwave? I know like Electro Boom does like videos with that. So you have like a primary and a secondary coil. Lim sup of the 1 0 sequence is 1, so 1 is upper bound. Or yeah, I guess it is. Wait, okay, let me just continue with the proof. Yeah, sorry, that's true. For machine learning. Oh, I see. Yeah, that's true. E to the 2I pi. I don't know, for some reason I was thinking about like the strict upper bound, but I mean, if you think, yeah, the definition says it's less than or equal to, or greater than or equal to. Anyways, checking when it converges absolutely. Okay, so for all epsilon, we have that this it follows that the power series converges absolutely when this is true. There's some epsilon naught. Okay, so we know it's Um, okay. What am I studying? I'm doing, I guess I'm doing some like analysis. I was actually supposed to do, or I'm doing ODE, but this is like a tangent I'm on. If in any case of that, okay, let's see. So Alright, right, so for this to diverge, we need to have that this this is less, or absolute value of this is less than 1, or yeah. And so and then we can solve for epsilon, and then we would have that. Okay, well, first of all, let's make life easy. So this is always greater than 0, greater than 1. I think strictly greater than 1, since this is always a positive number. I think this we just need to choose to be greater than or equal to 1, or rather we need to choose so it's greater than 1. Indeed. Or rather, I should say that this should be greater than 1. Therefore, like if this is the case, then we know that it diverges. And then we just need to choose epsilon to be what is it? So L minus 1 greater than 1. Wait, does this make sense? Maybe not. Actually, I'm not like, okay, this is, I guess, how to be greater than 1 over L. And then I need to show that the series CK minus K or K diverges. So we show that it doesn't absolutely converge. If this is the case, then we have that this we know that this is greater than CK times 1 over L, and then we have that yeah, so this is less than the limit minus any epsilon. And let's see here. have the k, and then right, so this would be 1 over k as well. Then I'm not really convinced about the epsilon naught. Like, so we say that we can pick it to be small. For all x, so that x minus, and this is greater than this, like the distance from a is greater than this. In this case there is some epsilon naught, so that I guess, okay, so if we only have 1 over L, I guess we have some problems, since this will not be less than 1 or greater than or equal to 1. So we know certainly that x minus a is greater than 1 over L, and let's see. I mean, in this case, it says that there is some epsilon naught. I would say that why isn't this the case for any epsilon naught? I mean, we assume that x is more than 1 over L away from A. So this will work for any epsilon naught. But I guess, like, I mean, we're fixing a single epsilon naught, so that this is true. I've been watching you quite a while, thinking 2 years now. I was to learn applied linear algebra, calculus, statistics, and have a strong foundation since I'm majoring AI/ML. Alright, cool. I mean, when it comes to applied stuff, maybe not the best guy to ask, but yeah, I mean, I can only recommend like what the books I've read, which is, I guess, not applied at all. So so I don't really know. I don't know any books regarding that, but yeah. I mean, maybe take some courses in your university or at your university. Probably there are some like applied stuff you can take. I know in my university there's computational linear algebra or something, or numerical linear algebra, which my friend is taking, and yeah. Since I watch your VODs, do I even have, or like on Twitch? Yeah, I guess. I mean, what even is a VOD? Is VOD just like a clips from a stream or an archive stream. I'm guessing so. Well, yeah, thanks for the support, Envy. Appreciate it. Pass all live stream saved for anyone to watch. Yeah. What does it stand for? Like, I don't even know. Does it have like a nice? Is it like an acronym or what? I don't know, maybe I'm misinterpreting this like a bunch. I'll just ask ChatGPT to be sure. Since yeah, I'm not entirely sure if I'm interpreting this correctly. I'm picking epsilon naught. We are already assuming x is strictly greater than 1 over L away from A. So would any positive epsilon naught work? To get that x over L plus DeepSeek more reliable? Maybe, but for me, ChatGPT works pretty well. Is there an aid or scholarship program for overseas students at Lund? I'm pretty sure there is. Maybe? I mean, I've seen a lot of scholarships, but I'm not sure if those are scholarships you can only get if you're already like studying at Lund, if you want to study abroad or something. ChatGPT sucks? I wouldn't say so. Not any positive epsilon will work. You must pick epsilon smaller than the actual gap between you're in the case where x minus a. Since you're in the case x minus a greater than this, define the gap choose an epsilon naught with I mean, I mean, if we have A here and then we have this distance is A. I mean, I guess ChatGPT is saying like if we have X here and this point here is 1 over L, we choose, or maybe not. Why would you do half then? Am I missing something here? We're already assuming that it's more than this. What's going on? Maybe, I'm not sure who is hallucinating, me or him, or like ChatGPT. I use it for program, like suggesting stuff, and it's useless, so I thought it sucks for math too. I mean, it depends on what, I mean, I agree that I would say it has gotten worse from ChatGPT 4 to 5, but it's still pretty good. If you have thinking, or I guess auto works fine, but I guess I would pick thinking. It would be better. Then it gets pretty good answers, or like you get pretty good answers. I don't get this. Like, I don't get this at all. I don't know, I think ChatGPT is kind of hallucinating. I think so. Let's see. This is always greater than this, and this needs to be greater than 1. Find this. So we get L minus epsilon. We just need to make this greater than or equal to 1. And we choose epsilon to be like that. Not smaller than the gap. The key inequality simply becomes false. I mean, I guess so. Bro, this is some spooky behavior. Yeah, okay, apparently I'm a bit slow. So I guess it makes sense. Yeah, it does. Blah. Of course, it makes sense. Of course. Of course, of course. Yeah, I'm not sure. This last step is pretty weird, but it makes sense. And yes, so basically, it's not absolute version. Okay. Yes. Okay, let's try to do case 2. That is 0. So in this case, we have that r is infinity. So we need to show that. I mean, if the radius of so. Let's see here. So 4 we limited or something like this. Is like subcase when x is like this. Such that, or I guess, I mean, it's always, yeah, so pick any x, show that this and all right, so what we can do, or rather we can show that it absolutely converges. We don't really have any other choice for x, so indeed. So let's see here. Here we have this. Okay. So we know that this is less than or equal to, or wait, is less than or equal to epsilon for all epsilon 0. Well, I just noticed this is kind of weird. We're choosing n here. But here we have k, so it doesn't really make sense, the index. Let's see. I mean, wouldn't this be true for any capital N? Like, I mean, for all indices, bro. I feel like I shouldn't get stuck on this, but for some reason I am. Like, if the lim sum is fine, we have that for any. Like, L is always the upper bound. I mean, n can just be chosen randomly, no? Hello, Rosie. Welcome, welcome. Bro, I spent 2 hours on this. Okay. I mean, it's kind of annoying me. No, wait, or doing math, yeah. At least trying to. I'm kind of like, I feel like today is one of those days where the brain ain't braining anymore. Just like this does not make sense to me. Anyways, I'll just kind of... Right, so this should work for all... I'll use n here. I mean, I guess my excuse is that I don't know if this is a typo or not. I mean, this like PDF is not really that. It has so many typos. For all indices. And then we see that this is true, so we can bound this guy by epsilon n. So we have that epsilon, right? So we know that we can like this, and then if just as long as this is less than 1, or I guess the absolute value here, and we are considering absolute value as well. Then this diverges. So what does this mean? So if yes, so if this is less than this, like this, meaning that, and this is for any epsilon, right? So meaning that for any like for an arbitrarily large number, 1 over epsilon, or 1 over absolute epsilon, we have that the power series converges, and then we're done. I don't understand the need to say that there exists an n. We always know that the lim sub is the, like, this always exists. I mean, it can be infinity, but that's, I guess that's fine. And this is always the limit of something. So saying that there exists an epsilon is just weird to me. I'm not sure if there are any big brains in the chat, or I mean, not to like any mathematically proficient people. You're not necessarily smart if you do math, and yeah. I guess vice versa. If you do math, you're not necessarily smart. I feel like I'm in that category at least. Anyways, let's see here. So I'll just see if ChatGPT can make any sense of it. Biscuits. Okay. No. In the text. Why say that there exists an n so that for all n greater than I mean, it's redundant. This should be equal to 1 over n, right? It's less than or equal to L plus epsilon. Isn't this redundant, since L is always an upper bound to the sequence, to the lim sub, or not, to the sequence. So whatever, so for any n, this would work, not specifically for a chosen caption. Something like that. I don't know if it's wise for me to spend this much time though. Let's see. Like this. I want to move on to a couple other theorems, and I want to do them myself. I don't think I've ever done. I took this course. I mean, these lecture notes are based from a course. I did this last semester, but I haven't really done any proofs that rigorously. I kind of just looked at them and said, fine. That seems reasonable. How can I learn math? I'm struggling and I want to learn programming. And I am stuck in basic math. I skip high school lessons. Well, I mean, I guess you answered it yourself, no? I mean, or maybe not. I mean, I would say just find a textbook and try to do the problems. I mean, mathematics takes a lot of time, and it's it just takes a lot of time to become intuitive and learn mathematics. I mean, if you feel like you're lacking like high school math, maybe buy or borrow one of the like a high school math book, like pre-calc math book. I think the Math Sorcerer has pretty good Math Sorcerer. I think I spelled it right. Yeah, Math Sorcerer has pretty good recommendations when it comes to books. He has so many books. Anyways, Great I. Limit is not an upper bound for the whole sequence. Am I crazy? I don't think I am crazy. Maybe I am. Alright, so is there a counterexample that I'm missing here? So, like, if I have a sequence, we're always picking the largest member. I mean, if you're always picking the largest member, lim sub is L. Right, so we would have a sequence like n even, n odd, n plus 1 over n, n minus 1. L, and then it would slowly go here. And then this one would just be constant over here. I mean, the lim sub would be be this number. I don't know what's going on. Man, this is not good. I kind of messed up with the definition here. Right, so it's the I guess this is the following envelope. Yeah. I thought it was the previous members, right? Alright, yeah, so it's like the supremum of the tail infimum sequence, a tail supremum sequence, as they say here. Brother. Well, in that case, do I agree? Right, so we can have, so the limit would be L, or lim sub would be L, and say that there is an N such that right, so we have an epsilon here. We can always let's see. Okay. So in this case, it's not redundant at all. Fantastic. Okay, I think we move on. Or no, let's actually finish the proof, I guess. So we have that. This goes to L. So instead of saying for all n, we say that there exists a capital N, such that when n is greater than this, we have this. And we can bound this, and then we know that this is true. Yes. Okay, so case when it's infinity, I think. So when L is infinity, so 1 over L is equal to 0. So I guess when this is the case, we have that what do we have? Right, so let's see here. Let's do CK here. When it's equal to A, we have 0, so I guess we have that. By the way, hello LK, welcome. Nice to have you here. Okay. Alright, I think I'm gonna take a little bit of a break, and afterwards I'll move on to some stuff here on ODE. I feel like I've done enough, but I do want to finish case 3 and then I'll move on and try to do all these problems, and then hopefully I'll move on to chapter 5 after that. Anyways, actually I don't think I'll do chapter 5. I still want to finish up chapter 4. But yeah, all right, I'll see you guys in like maybe 30 minutes. I'll grab some food. You know, maybe I'll put a disclaimer. Dinner break. Approx 30 min. I'll do red. Yes, sir. Means you have Discord? Yeah, my laptop is like kind of shattered. Like the screen is shattered, so it's not really possible for me to join. Or maybe if I turn off the so basically my screen is like touch. I mean the display, like the LEDs and stuff work, but it's like the touch on the screen that's always being messed up. So that's if I can manage to turn it off, it would be great, but I haven't been able to do that yet. Maybe in the future I can find some way. Alright, but anyways, I'll be back in a couple minutes. Alright, there you go. Excuse for the long break, my mom just came home and I had a long conversation. There we go. I think that was more like a 1 hour's break, but it is what it is. Let's continue. Where was I? Yes. Case for L is infinity. I have a series diverges and hello Sumaya. What did I have for dinner? I had some leftover food, but I mostly spent talking to my mom. So let's see here. Right, so we know it diverges, so we know that CK like this. We can find an M that such that this is greater 1 over K, CK, K. So wait, let me see. So we want to try to compare it with something less, and maybe this is not the way to go. For some reason I find this fairly challenging. It shouldn't be that difficult. No, I'm doing this wrong. Yes, I'm doing this wrong. Yeah, so we have that for all that this for all epsilon we can or for all m we can always make this greater than this, and will this do anything to us? I'm not sure if this is correct though. I mean, if we show that it's not absolutely convergent, then for all x we should be fine. So right, M and I mean this we can make greater than 1, since we can always choose M to be any number. So if this is greater than 1, we can choose M to be 1 over 6. So yes, so in that sense we can always make this greater, or like for all m we can choose a sufficiently large capital like capital K such as small k. It's always greater than this. So, I mean, if we choose m sufficiently large, then this will be greater than 1. I think this is the logic, at least. Yeah. All right. Let's move on. I want to do some of these proofs here, and I also wanted to see a little bit regarding what I'll have tomorrow. So I'll have ODE. All right. So it's probably a good idea to read chapter 5 though. I haven't read it. Even though I probably won't be able to complete everything that I want to do. All right. Let's see here. Follows there from definition. We have that. Number 2, choose x to be the EK. 1, then AK is equal to this. Let's see. Yes, so yeah, of course. HK. This is less than this. I guess. And this is less than A. Oh, interesting. Here we have Cauchy-Schwarz. Right. So this is like the geometric or the Euclidean norm. If that were for all the elements. What's up? Hello, Specialize. Hello. Also going to do some differentiation with Darin now. Alright. Well, good luck, Vanessa, with that. Data science. I'm not doing data science H. I guess I remember I took like the CS50 Harvard online course, and then that's basically where my CS like interest started and kind of ended, to be fair. But like transformers and other, like when it comes to large language models and deep neural networks, it is fairly interesting, I guess, but I don't think it would be something that I would spend a lot of time on. I mean, it's interesting, but it's not really something that is I would do, really. We're into pure math, physics stuff. I mean, I wouldn't say physics. I'm just more into pure math, I guess. Like kind of this stuff that I'm doing. I mean, I don't really enjoy programming. I don't like doing that. And so yeah. I don't know what this is, but is this the same Cauchy of the mean value theorem? I'm not sure who proved the mean value theorem. Was it Cauchy? I don't know. But what they mean is the Cauchy-Schwarz inequality. Oh, Schwarz. If I remember correctly, let's see. Don't like coding, but I like data science. Yeah, cool. Do I remember this? Right, so I think this is where we apply Cauchy-Schwarz. You have right, so in this case it's the so like this, the scalar product between UV square less than or equal to Yeah, I'm not entirely sure actually. I kind of forgot. I mean, it was something to do with this. Oh yeah. Or was it with norms? All right. Well, I guess you can write it like this. I mean, if we have a, but I guess this is the same as. But I mean, I guess if we have an inner product space, the norms are not necessarily the induced norms from the inner product. I think so. I think this is the more correct way of writing it. And with the sums, this is just a special case where we choose that the inner product is a scalar product. Anyways, I'm pretty sure. Okay. So in this case, yeah, we use it here then. JK, right, so we can just wait. And the statement follows from the definition of matrix norm. Let's see. I'm not sure if I understand this step here. So we have this sum. Oh yeah, this is just a this is just equal to all of the guy squared. But then we're summing right for all k. Okay, yeah, I guess that makes sense. And then we get this. So indeed. Right. Let's see. Oh, let's see. Oh yeah, sorry. So the argument was that we can write this as AKJ XK and this is this equal to, wait, no, let's see. Let's see. Yes, of course. Yeah, so of course we first get the so it's the jth row, and then yeah. So firstly we do the matrix times the vector, and then we get that the absolute value applies to these guys, and this is for every k, and then we apply it for j. I mean, I was thinking triangle inequality, but in this case it just naturally comes from the operations. All right, and then we can use Cauchy-Schwarz here. I just want to do it myself just to get a feel for it. So this would be the norm of, and then we use the Euclidean one, so AKJ, and then, let's see, it's a square, so this is just a square, and times K for K for K is a square. All right, and we also use the triangle inequality here. I guess that makes. And then we can. It is also divided by this, and we have this up here as well. And this just becomes the norm square of this guy, and this is just jk of akj square, and then we divide this by let's see here. Square this. Should be a square there. There we get this. And this is the square of, let me see. Yeah, it works. Are we trying to prove this? I just want to go through the proof like myself a little bit, just to get a feel for it. But yeah, it's clear. So I'm not rather trying to prove it myself. Alright, I think this is good. So I wanted to look at it since I want to solve 34. Right, so here we see that having this, and I guess we have x here, right? Yeah, it'd be x. And and this we can bound by this argument by b, since okay. I don't know, it seems for some reason I'm very when I see the sup I'm constantly like on the guard, but I guess yeah, I mean my like my brain just wants to cancel the x's, but this is not really something you can do, right? So you multiply first and then you can do it. But in this case, like you have a free x here, and just cancel this, and the sub just disappears since we we have no x in this in the thing, like in this supremum. So in that case, the supremum just disappears, and we get this number 5. So how can we use this to show 34? I really love calculus and function in high school, but I feel like university math is way different. Oh, yes it is. I mean, I guess it depends if you're doing like engineering, but mostly it's a bit way different. Which I think is a good thing. I never liked high school math. Yeah, but anyways. I worked on 34 before, I think. That is like my tangent. I just went here and then okay. Okay. Let's see if I can do something. I'll just do 34. Okay. So AX. I mean, we know there exists a basis of eigenvectors. So can we somehow use this? Not entirely sure. Reason you like digital notes over written? I mean, I always write on paper, but just for the streams I do it digitally, just so it's visible, you know. I'll see if I can get a hint, because I've been stuck on this for a while. Please give me a hint to solve this dance. Show if the following answer is true, if and only if A B is equal to BA. Work with the 2 norm. Try X as a unit eigenvector corresponding to an eigenvalue of largest magnitude. Oh yeah, well it does remind me of something in linear algebra, but I can't completely remember it. Corresponding to the eigenvalue of largest magnitude. I don't think this is really helping. For any matrix A, rhythm fits. Hum. Try X as the unit eigenvector corresponding to the eigenvalue of largest magnitude. See if I can open up the linear algebra book, see if I can gain some knowledge there. Spring. Right. See if I can gain some knowledge. quadratic form on a non-zero finite dimensional product. Yeah. Cubic quadratic form on an n-dimensional inner product space, and let this be eigenvalues. Then lambda 1 is the minimum QU. Right, so QU is I mean, this looks like awfully similar to like the operator norm. I'm just wondering if there is some, has to be some correlation. Diagonalizes Q. Wait. Q is from V to R. I think. Be ordered so that EI corresponds to lambda I. 1 to n, let U be any vector of length 1. Yes. When you reduce all overall non-zero vectors, ratio of all goes from and what's up, James Grind? I mean, it's going kind of meh, I would say. I'm getting really sidetracked and stuck, but it is what it is. I mean, I guess that's just the nature of things, but I would have liked it to be a bit smoother, not gonna lie. I'm just kind of stuck on this problem, and yeah. I'm a little confused about Q, like of the matrix of Q with respect to any orthonormal basis. This is what we mean. Yeah, I didn't really understand Q, so right. So we know that any Q can be written as X transpose. We have the bilinear, or like the quadratic matrix, I think it's called. Then yeah, definitely my linear algebra is rusty. I need to freshen it up. Eigenvalues of Q are the eigenvalues of the matrix of Q. Yes. So eigenvalues. Okay, so it's quadratic. We know that, I mean, if we know that B is symmetric all the time. I'm just wondering, like, is it like an if and only if thing? So does B symmetric mean that it has a corresponding bilinear form? Wait, let me first of all write it down. So we have A1, A11, A12, A1 or 21 or A22, and then we multiply it by x1, x12, and then x1, x12. So here we have right. So I mean, it's associative, so it doesn't matter how we multiply it, but yeah. Yes, we get A11, x1 plus a21, x2. Oh wait. Oh, this is supposed to be like that. A21, x2, x1 plus. Right, it's supposed to be symmetric as well. I forgot. Wait, actually, let's just do this for now. Plus. Yeah, so this is x2. This is x2 square. Okay. And in this case, we have a12 is equal to a21. So we get let's see. Right, so we have that each of the term has like the sum. Actually, I'm not really sure how you say it, but I think like the order of each term needs to be 2. Yay. Okay, let's see here. So basically we need to show that A is equal to the max. Added 1 there. So here we have that the max of lambda n is equal to this. Let me just see here. So I can instead do that. This needs to be 1. Then we have this. Not totally sure how to do this. normal Q and real eigenvalues, then a squared is equal to this. Is this true though? Not totally convinced. So we can find an orthonormal basis. So suppose that x be any vector of length this is not really going that well. Let's see if we can get another hint. Another hint, please. I just don't seem to understand where to even like start, you know? I mean, in this case, where we have a quadratic form, it seems intuitive that the maximum of the quadratic form to be equal to maximum of q, right? So q is a real value, and in this case we have a real value here as well, right? So if we square both sides, so if we have that this to be squared, we don't, because here we get some square root of something something. If we do this, we don't get this. We get square root. So in the sense we get sub of so each of the columns right, so we have that like C1 scalar with x, and we have basically the sum here, I there, but will this help us? And then let's see. Yes, I think if we work in the like the basis, like if x is like coordinates, or if we basically do the similar thing we do in theorem 7.9, maybe it will be good here. By the way, hello Rafaz. let me think for a moment. So if we have the basis, right, so we have E1, wait. And its vectors E1, eigenbasis. A let X so yes, so i.e. x be equal to x1 dot dot dot. Okay, and no, rather let's see. Okay. Trace by a unit vector in eigenbasis. Yes. Okay. So we can write this as alpha 1 of E1 plus alpha n en. We have that a x basically I want to get this to be what? If I can get this to be, I guess, hello Orla, welcome. Oh. Yeah, this makes sense. I mean, this is... I mean, it's all good, you know. I mean, we have here that E1. I mean, we get alpha 1. Honestly, I should do a stream where I just go through the entire linear algebra, because this is kind of rough, honestly. I'm start a business space. So I started. I should go to college. Find it useless, as I would learn more by doing things myself. I mean, fair enough. I guess that's kind of interesting. I mean, I've seen like a lot of people in. I mean, I've only seen this in like the US, where people actually drop off and stuff, and stuff like that. But yeah, I mean, for some majors, it makes more sense. I mean, if you want to do business, I mean, sure, that makes a lot of sense. Yeah, so we have this times something, the eigenvector here, which is equal to the corresponding eigenvalue times the eigenvector there. And yeah, this is just the sum from J. You know, I want to do a stream where I just go through like the Linear Algebra Done Right book from top to bottom. Maybe it would be nice to do like nowadays it's I mean, I've seen recently Speed did like I think it was a stream across America, like 24-hour stream. And what if I do something similar but with mathematics? Maybe an interesting idea. Maybe actually. Or just do the entire linear algebra book. Granted, I needed a lot of free time. Probably something you would do during the a holiday or something. Anyways, okay. You know, algebra is a good idea, but not the 24 hour. Why not? I mean, I guess I wouldn't do mathematics for 24 hours, but I would, you know, still go sleep and stuff. But just have like a continuous stream. Or maybe you can do just consecutive. I mean, just end the stream and have a streak going, like episode 1 of linear algebra on the right or something. I guess that works as well. Cause sleep, yeah. I mean, I think it would take me at least a week of non-stop grinding, or even more. Actually, I don't know. It would be interesting seeing how long it would take me to go through like every problem of a linear algebra book. I don't think I mean, I've done linear algebra, and I mean, I got a good grade in the course. I got the best grade, so I mean, on paper I am qualified, but I don't think I'm really that qualified. I mean, yeah. But certainly the first maybe 100 pages I would get through pretty easily. Or, yeah, relatively easily. Because I do have a good foundation, but later on, especially in this book, the last chapter I kind of like skipped. I usually do this with like every course. Like the last chapter is always something that I don't do for some reason. It's the same with the book here that I had on called the Introduction to Higher Analysis. The last chapter I kind of skipped, and arguably it's probably the most important chapter, especially for what I'm doing right now, the course I'm taking right now. Anyways, we can bound this by j max of lambda j between n, j between 1, of j of alpha j x j, and then we can factor this guy out. And then you get the coordinates of x. It's interesting you're even using textbooks. I don't think it's super common in uni courses here. Lecturers prepare their own slides / notes exercises. Seriously, wait, you have to have a textbook, right? I mean, here, some teachers prepare their own. I mean, this is a lecture notes from that one of the lecturers did a couple of years back, and this is also lecture notes for someone did. Like, I won't say his name, but that my professor did. So, I mean, you have to have like a course literature. Surely you have that, right? Be it your professor's notes or just a book online. Yeah, this is exactly what happened, like what was done in the previous oh, I forgot the square. Oh no, I didn't. Wait. Yeah, so here it's supposed to be x squared like this, I think. This is supposed to be squared here. This is all squared. Yeah, this is all squared. And then, yeah, and then we're done. Yeah. At least for biomed, they recommend a few textbooks each course, but seniors usually don't recommend going through them. I just learned everything from lecture slides, some extra reading. Yeah. Alright. Fair enough. Craze rock. Alright, I think I'm convinced about this exercise, and it's really similar to this one here, where I guess what kind of confused me was like, of course you can write x in terms of this new basis, and these coefficients will be the coordinates. Alright, so I kind of got confused by the idea of coordinates. But yeah, if you write it as like a linear combination of the like the eigenvectors, and you work with the ax term here, and you try to, or actually now that I think about it, I'm bounding it by this. When inequality holds, what's to say? Yeah, so I don't think I'm. So this is supposed to be equal. When does equality hold here? I see, maybe. Wait, what? Yeah, I don't know why I wrote x here. Yeah, this is supposed to be e here. Right? It's supposed to be EJ. So when alpha j is equal to 2 is equal to alpha 3 is equal to alpha n is equal to 0. Meaning when x is an eigenvector, the equality holds. So oh, I see. So x needs to be the eigenvector corresponding to the greatest eigenvalue. Then equality holds. Right? Equality holds when this is the case. Right. So what does this tell us? Equal to EJ. for I guess I can write so we have that. Hello, mystery. I do think textbooks are better than lectures, honestly, as a biology student. It depends if you're someone who prefers understanding the general idea or the details. I mean, I guess both are important. I wouldn't say one is better than the other. I feel like it's I don't know, you get an idea of what is expected when going to lectures, and also it helps hearing someone talk about what you're going through, basically through the reading, and make sense of your ideas and stuff. ChatGPT, a good help. I've tried using when I was revising high school math, and it made a lot of mistakes. Alright, well, I would say it's very, very good. It rarely makes mistakes, but it does happen, and I've experienced it many times. But in general, regarding mathematics, it's a really good tool, and I think the key is to view it as like a study buddy rather than an authority. In that case, you're not really like, yeah. You should be skeptical, and if something doesn't make sense, it's yeah. I mean, you should use it. You should think like, you shouldn't like not think and use it. It's made to complement like books and stuff, or at least that's what I think. And it shouldn't like outsource thinking, but it should rather encourage it. So yeah. Was that what you said in the German conference? Still waiting for the vlog? Yeah, exactly. That's exactly the quote I said in the conference. Shouldn't outsource thinking. AI should be used to encourage it. Yeah, the vlog, by the way. I mean, I honestly just... I mean, I have a fair bit of video, but... and I did started editing it, so... But... I guess I kind of just stopped. Are you streaming on YouTube? Yeah, I am, mystery. You can join there. I mean, most people join on YouTube. Oh, yeah. Trying to grow my Twitch audience as well. Okay. So, So the supremum of this wait, instead let's do this. So an x is any vector. In this case, I guess C would be, or X would be any vector in Cn maybe. I mean, this is how we define it like that, but I don't know if I'm completely convinced. Twitch on phone is really good. You can play picture in picture. Wait, what do you mean by that? Leave the app and it'll play a small window. Can YouTube do that? Or maybe if you have premium. I have premium, so that automatically happens for me. I mean, honestly, I really recommend premium, buying YouTube premium, because you get YouTube music and you also get like no ads and stuff on YouTube. So you basically get like a Spotify, and also life becomes easier on YouTube. And it's I think it's kind of like a life hack. I don't know if many people know this, that you actually get YouTube music for free. But I guess some people are like used to Spotify and they don't want to switch, which is fair enough. But yeah, YouTube music works well, I guess. I would say it's kind of like a good hack. Right, so the biggest value here is when is the maximum of ij, or wait, I guess when x points in the direction of the eigenvalue, or of the eigenvalue vector corresponding to the biggest eigenvalue. Like this, and in that sense it would be equal to the maximum ij. I'm not sure if this is a good proof, but I mean, I showed up here that this is the case at least. Yeah, and this is yeah, and this x is between any is any vector. So, and I showed that if we pick x to be equal to the maximum here, so, and then we get equality here. So in that sense, this is equal to this. Writing music for free is insane. I mean, I guess it isn't for free. Like, you still pay, but I mean, I didn't know that at first, so I just bought YouTube Premium just for no ads. But you actually get basically free Spotify, like without any ads as well. So it's just kind of nice. Granted, YouTube Premium isn't the cheapest, and it's more expensive than Spotify, but if you already are looking for like no ads and stuff, so then it's like kind of a steal. And I think there are like plugins where you can, or websites where you can transfer your playlist from Spotify to YouTube. So in that sense, it's not really a big deal. I did do this. I remember I had a playlist on Spotify, and then I just switched to YouTube, and you just like link your account in a website and does it automatically. life hack. Okay, I've spent so much time on this, but I think I say this all the time, but I think the only way to actually get good is by just pouring a lot of time. So I'm not really that frustrated, but at spending so much time on something that maybe I didn't feel like I should, but apparently I did need to spend time on it. I think it's time buying YouTube Premium because the ads are so distracting. Yeah. But I don't think I have ads on my streams, at least. I don't think so. I guess it doesn't matter. I mean, for me at least. I don't really get that much from it. So then we have this little guy. This one was a really good one. Like extra. This was basically just an exercise of linear algebra. It had nothing to do with ODE. Yeah. Okay, let's see. Maybe I'll continue with chapter 5. I'm not sure. I don't have that much time. Alright, let's do that. Here we are. I think. Okay. And I guess when I'm done with this, I'll go back because I don't want to be like a question mark during during the lecture tomorrow. So I think I'll just move on. I watch your ads in full for that ad revenue. Seriously? Okay. Well, I appreciate that. Okay. I mean, yesterday I had such a problem here with reparameterization. I don't know. Hopefully I won't be stuck with that. I mean, it was especially this like text that kind of confused me here. But anyways, yeah, and this proof as well. This is just a simple contradiction, so it shouldn't be that big of a deal. In both these cases, the phase portrait consists of closed curves. By reasoning as in the proof of theorem 1, one may show that then the solutions are periodic. Ooh, I remember this. I think I tried to prove this. I think so. Yeah. And I think I did it. It was very maybe like straightforward. I mean, if it's periodic by period t, we can. It means that this is equal to this, and since this or like these are the same orbits. Yeah, these are the same orbits since there is a. Let's see here. Yeah, right. So these are the same orbits since this like reparameterization yeah, so since this is just a reparameterization, this expression there's a one-to-one it's a one-to-one map. Yeah. So for each t there is a unique output t, meaning that for each point in a curve there's a corresponding point here. So this is a simple reparameterization, meaning they have the same orbit. Yeah. So what does that mean? Does this show it's periodic? Well, social autonomous this. Right, so wait. Wait, does this even show that it's periodic? Doesn't seem like it. A is a 99. What college year are you in? I'm in my second year currently, in the math program. Yeah. I don't think this shows. This definitely doesn't show periodicity. I don't think. No, it doesn't. Those points x hat in omega where f of x hat is 0 are of particular interest. Such a point is a constant orbit since x of t by definition is x. By definition x, or if you define x of t to be the x hat, solve system 1. I mean, I guess so. Yeah. So that So here's just the derivative of something is equal to this. And if this is 0, right. A point x hat in f of x is called equilibrium point of the system. Consider solution x of t with x naught equal 0 x naught. This is defined in some maximal interval where possibly if t is infinity. If t is not infinity, it follows from theorem 3 in chapter 1. Yes, of course. Or possibly t is infinity. Follows from theorem 3 in chapter 1. The t approaches the boundary of omega or moves infinitely far away when t approaches t from above. If t is infinity and x of t has a limit point, then x of hat is an equivalent point. To show this, we consider one coordinate xj at a time by the mean value theorem of differential calculus. For some tau between t and t plus 1. When t goes to infinity, the left hand side tends to 0 and the right hand side thus fj of t 0 for all j that is f is 0 there. Phase portrait. So a phase portrait was a solution or a solution curve. The set of orbits of an autonomous system is called phase portrait. Examples of phase portrait: consider the equation of a pendulum. We see example 3 in the corresponding first order system is this. In order to construct a phase portrait, we will use the fact that the total energy is constant on the orbits. Put the energy E of x1, x2. The first term represents kinetic energy. The second potential energy. That the function E is constant on the orbit 2 follows from the chain rule. Now we sketch the level curves. Obviously every orbit is contained in such a curve, and we obtain the following phase portrait. So just wait, what? Okay. Orbits of type gamma 2 correspond to the usual pendulum movement. Those points at which gamma 2 intersect the x-axis have coordinate where x bar is the maximum angle of deviation of the pendulum. The point gamma 1 corresponds to the case when the pendulum is resting straight down. A so-called stable equilibrium point corresponds to the other unstable equilibrium position when the pendulum is balancing straight up. The pendulum is balanced. The orbit gamma 5 corresponds to pendulum overshooting, and orbit given exactly the right approach to approach the equilibrium position gamma 4 when t goes to infinity. Gamma 3. These things have been generalized. Consider the equation for a particle moving a straight line, the y-axis under the influence of a force which is dependent on the position y but not on the velocity y gamma or y prime. The y-axis. Can we use to construct a phase portrait for the corresponding first order system, namely it suffices to change the second term in 3. So it means that the second term, so he has no potential? Bro, this is some physics right here. Right. Example 2. We could sketch the phase portrait by finding a function with a constant value on each orbit. We should always bear in mind is the geometrical significance of the system. The right hand side f of x may be interpreted as a direction field in Rn, which at every point x indicates the tangent vector of the orbit through x. We continue with some more examples. Ay. First quadrant solutions are easily find the solutions in the other quadrants. We sketch these solutions. The orientation is deduced. For instance, is negative when x is positive. The case xy0 remains, but when x is 0 y is 0, the right hand side 4 is 0. Thus every point on the on an axis is an equivalent point. That is, it is its own orbit. Draw the figure to show this. The face border has the following appearance. Am I convinced? Like, isopolar coordinates. We obtain this. Second equation means that this is true. The equation for R is separable, and also R is 0 and R is 1. The phase portrait has the appearance below. The unicircle is closed orbit corresponding to a periodic solution. All other orbits are spirals moving towards the unit circle. When t goes to infinity, the unit circle is so-called limit cycle. Wait, isn't it the... So you have the equilibrium. Stable equilibrium. This is the limit cycle. Ay, ay, ay. By various tricks manage to derive equations for the orbits. Even when this is not possible, you may still be able to obtain some qualitative information about the appearance of the phase portrait. We'll consider the system. A, B, C, D, E, F are positive constants. If you in the Volterra-Lotka equations from example 11 add correction terms of the same kind as in logistic law. We put the right hand side in 6 equal to 0. We find all equilibrium points. Okay. We're only interested in solutions in the first quadrant, and we are going to show that every solution with tends to the equilibrium point. This okay. First we prove that the orbit but where's the equilibrium point? I mean, I guess here there isn't an equilibrium point. Mayhaps. Here as well? Or is the equilibrium point at the axis? I think so. The right hand side is 0. Thus every point on the axis is equilibrium point. So equilibrium point is when the I guess when the tangent is 0, when it has no like velocity, basically. If this is like a path for some kind of path. Right, so if we go a little left, this flows to the left, and goes to the right, it goes to the right into the x-axis. But here everything is stable. Okay. And a limit cycle is all other orbits are spiraling moving towards the unit circle. limit cycle. So taking the limit is like a diverge, like a, okay, I guess the name speaks for itself. Okay, first we prove that any orbit originating inside the first quadrant cannot leave it. Okay. Otherwise, the system 6 would be impossible as a model of animal population. Wait, what? Okay. I'm guessing this is used for animal population. You can easily see that system 6 has solutions with y of t 0, solve the first equation with y 0. Solving the first equation with y0, you find that the positive x-axis contains two orbits inside the equilibrium point. Positive x-axis contains yeah, I guess so. Namely the line segments 0x this. X greater than this. In the same way, you find that the positive y-axis forms one orbit. Will never intersect the coordinate axis. Oh, right. Yes, you would solve this by integrating factor then to get this. Okay. Forms one orbit, since two orbits cannot be intersected by theorem 1, it follows that. Oh, yeah, I guess that makes sense. So basically, I don't even know. Let's continue here. 5.1. Like, so here is an equilibrium point. Equilibrium point. And this is at 0 or AE0 for AE some fixed real numbers. And then by solving when y is 0, we see that we gain two what do you call them, like orbits, I guess, yeah. And then when x is 0, you see that we have orbits here, and therefore we have like a prism, so any orbits here can never intersect, which I guess is fair enough. Are we going to study the whole textbook? No, I'm not. I mean, the course I'm doing is not on all chapters. Chapter is just chapter 0, 1, 2, and then 5. So I guess chapter 3 and 4 are skipped. But this is kind of cool. We now study system 6 inside the first quadrant. By the way, let's see here. Okay. As we have noted earlier, the first hand describes a direction field of tangent vectors to the orbits. Yeah, exactly. Right, so if you graph this, we would get, let me think. Yeah. We get like the direction of flow. I'm not sure the English name. How much of you didn't get when you started? Hello, Madhur. I can't say that I totally like recognize your name and stuff, but yeah, welcome. Like, since you had algebra, did it help at all? I'm not sure what you mean, like how much I understood. I got into college, I failed you during G preparation. That's awesome to hear, Madhur. Congrats on getting in. Very, very cool. What are you studying now, Madhur? I mean, I guess in something engineering, right? Those points where the orbits have a vertical tangent are defined by this. That is that when x is positive, this is the line In a similar way, you see that the orbits. Wait, let's see here. The orbits in the first quadrant have a horizontal tangent at the points on the line. These two lines split the quadrant into 3 regions, each which with a constant sign puts the intersection of the line outside the first quadrant. I see. Consider first region A. Due to the direction of the field on an orbit starting at A cannot leave this region for B. Neither can it intersect the axis, thus an orbit originating in A or on L1 will remain in A in all future. We shall see that it converges to the point since x prime of t is greater than 0 in A, the function x of t is strictly increasing and the function y of t is strictly decreasing along the orbit. These functions are bounded. As a consequence, they have a limit. Oh. And the function y is strictly decreasing along the orbit. Furthermore, these functions are bounded. As a consequence, are they bounded? Pursuing electrical and electronics engineering. Nice. Cool. When you started calculus, did it help that you knew algebra? I mean, some algebra is certainly necessary. I mean, actually yesterday I had a couple students that got stuck on an induction proof, and I felt that they didn't really know algebra that well, so they got stuck on the concept there. So certainly you should be familiar with the field axioms of the real numbers and how they implement them, and be confident in solving equations, basically. But when it comes to abstract algebra, it's certainly not useful, or in the context of calculus, it's not really useful. Probably for higher level analysis, it's useful, but in low level, knowing that R is a field and field axioms, and yeah, that's basically it. Functions are bounded. Are they bounded? Right, so I guess by the monotone, what's it called, the bounded monotone sequence or theorem, or I don't even know, balloon lemma, as I like to call it. And as a consequence, they have a limit when t goes to infinity. The orbit converges to some point, but we have earlier seen that then this point is an equilibrium point of the system since x of t is increasing. is the only alternative. I guess so. Like this region. I mean, if it. Let's see. I consider an orbit starting in region B. From the signs of the derivative, it follows that both as long as the orbit remains in that region, the orbit can pass from region with the direction of the field, and neither can any orbit intersect the axis. It follows that an orbit leaving B must also move into A, and then we already know that it converges to this. On the other hand, if the orbit remains in B for all t, function xt are bounded from below. If they're decreasing, have a limit. With the same as before, the limit will be this. Finally, an orbit originating in region C must end up passing into B, because otherwise would have limit values. But there is no equilibrium point in region C or on this boundary. Ew, I guess, let me think. I mean, if it has a limit, then it has to, if it has a limit, then the limit, like, then it has to go to an equilibrium point. The limit has to be an equilibrium point, right? But there is no equilibrium point in region C or its boundary. In conclusion, all orbits with origin inside the first coordinate will converge to the equilibrium point. For our species, this implies that the predators little by little become extinct, while the prey reach an equilibrium. Population A divided by E. You can solve this order linear differential equation with initial condition. Oh, you're asking if I can solve it. I mean, this is just a linear, or no, it's not. You have an exponent there. I'm not entirely sure. I'm gonna continue reading this. Yeah, I don't want to go too much over time, but I mean, it seems like we have Yeah, I'm not sure. Actually. Like, is there a general solution to this? I'm not really sure. I give precise meaning to some of the terminology introduced above. An equilibrium point of a system is called stable if to every number epsilon there is a delta such that oh yes, of course you can use integrating factor. Yes, of course. Yeah, sorry. An equilibrium point x of the system is called stable if for a number is stable and the number delta may be chosen so that x of t is a solution of the system. An equilibrium point which is not stable is called unstable. Asymptotically stable. Origin is stable. Right, well, x of 0, like wait, let me look here. So the equilibrium point was I see. Yes. So when it just is when it has no direction, if this is the flow of like a particle, then that would be the point where it doesn't move. Can you share the name of the book you're studying? It's called, I think it's actually linked in the description, and yeah. But you're not gonna find this book online on a PDF like this. I've scanned this in manually, which took a lot of time, but it's not really a popular book. I don't know a good alternative that is readily available. I think I did ask ChatGPT once, but I haven't really looked into that. But yeah, this is basically just the course literature that for the OD course I'm taking. Yeah, obviously I'm still frustrated that you can always use integrating factor. I guess what was putting me off was x was not linear, so it kind of put me off there. But it doesn't have to be linear at all. Ay. My brain is like kind of fried. How long have I been live? 6 hours. Isn't ebook strained to your eyes? I mean, I feel like ebooks or like PDFs are a lot more efficient. So. Or unstable equilibrium points. Yeah, so here we can make the solution curve arbitrarily small to, or arbitrarily close to the equilibrium point. Given we choose that x of 0. I'm not entirely sure, like, is 0 just like, what is the significance of choosing x0? I mean, we have a fixed x0, or like x hat. In many concepts, it is of interest to decide whether an equilibrium point is asymptotically stable, where the solution starting close to x hat converges to x hat when t equals to infinity. For instance, do questions of the kind play an important role in control theory, where the object is to design mechanisms to control different kinds of processes. We return to these problems, section 5.3. how can you interpret equations in your mind? I mean, practice. But yeah, I mean, I'm myself having a little bit hard time understanding, but I feel like this specifically what x naught here is, like, what is the variable here? I mean, we need to have that the distance here is delta small, so that we can make so that the solution curve is arbitrarily small to x, like the equilibrium point. It would be good to actually do these, but I'll just continue reading since I don't have that much time. So we'll move on to chapter 5.2. I feel like most things made sense, but I certainly need to practice doing the questions and computing the things, like the examples and stuff. Say 8 hours a day with college or self-study only. Probably 8 hours seems like a reasonable amount that I do. I mean, I'm not stating anything about studying 8 hours a day. I used to do that, but not now. But usually I would count study time to be, like, if I'm in college, like seminar or lecture, 8 hours, like I would count that as study. In order to further acquainted with what a phase portrait might look like, we are going to make a detailed study of linear systems in 2 dimensions. Such system is autonomous, means that it has constant coefficients. Let's consider it is obvious that the origin is an equilibrium point, and if determinant is non-zero, this does not have eigenvalue 0, it is the only one. We assume that this is the case and leave it to the reader to investigate what might occur when the determinant is 0. Phase portraits of linear systems. We split up in different cases depending on the eigenvalues of A. Note that we have assumed that A is not an eigenvalue. A has 2 real separate eigenvalues. Let V1, V2 be eigenvalues, number 1, number 2 equals eigenvalues. Theorem 6 in chapter 2, page 103. The general solution is this. If we choose V1 basis on the plane, the solution coordinate form. Elimination of T results in where this is this, and C is a constant together with x1, 0. I guess so. I guess that makes sense. Assume first that this is true and they're negative, then converges towards the origin, which thus is asymptotically stable equilibrium point. All orbits except x2 is equal to 0 have the x2 axis as tangent. Is a so-called stable knot. The heck? What? How long is your summer break? My break already ended, but I started June, I think mid-June, and then ended September 1st. So fairly decent, like full, like more than 2 months, like 2.5 months or some shit. The origin is supposed to. And the phase portrait has the following appearances. All solutions converge towards the origin. Instead, when it's positive, the solutions have reverse orientations. The origin is called an unstable knot, meaning that all solutions diverge. I think. Finally, assume that the eigenvalues have different sign, and then the solution origin is saddle point. All the solutions that converge to the origin are x1. When x2 is 0. Orbits parallel to the eigenvalues of v1 are sometimes called separatrices. The heck is that word? Note that every coordinate axis contains 3 orbits. 2 separatrices and the origin. Wait, what? Notebooks on a summer break? Oh, that's a good mention, Pillar. I should change that. Yeah. Is it actually true? Well, actually, I don't think so. Like, on YouTube. Well, it shouldn't say that. Orbits parallel to the So I'm guessing these guys are the separatrices. I want to say separatists. A has a single real eigenvalue. A has 2 real separate eigenvalues. If A is diagonalizable, then this is true, where lambda's eigenvalue. The general solution is this, and the orbits have equation. If lambda is greater than 0, If lambda is greater than 0, the first course looks like the origin is a star point. If A is not eigenizable, denote by V an eigenvector, then lambda the eigenvalue, and let W be a vector not parallel to V in the basis VW. The matrix of the mapping A has the appearance here. In fact, beta is lambda. The characteristic polynomial has a single 0 lambda. The general solution of the form. This may be verified, for instance, by insertion or by the application of formula 17, page 8. We're back in diagonalizable case. Show the faceboard. The origin is an unstable improper knot. An improper knot, what does that mean? Right, so if it's unstable, then maybe I'll give like the definition to ChatGPT, because I'm not sure if I completely understand the idea of an unstable, or rather the equilibrium points. I don't really get the intuitive picture here, especially with x naught. As I understand it, if asymptotically stable, then okay, rather what is x naught? Isn't x naught minus x hat a constant? Equilibrium satisfies this. Yes. If you start exactly at, you stay there forever. In the condition, in the definition, x of t a solution trajectory with the initial condition. So x naught is simply where you drop the system time, right? So if you drop it off delta close to this, it implies that x of t, right, so for any, I see, meaning that if it's stable, we can find an initial value that is delta close to the equilibrium point, such that such that the solution curve is less than epsilon from the equilibrium point. Yeah. So yeah, basically meaning that if the initial condition is close enough, then the solution curve will converge to the equilibrium point. I think, at least. I'm doing my BTech from Moscow. Oh, nice. My mom is from Moscow, and I've been to Moscow a couple times. I think it's a good place. I like Russia. I think it's I mean, it's sad what's happening there, but in general, I think the people are great. Especially in Kaliningrad, I have my grandparents live there. Yeah, it's like a totally, it's a different vibe, but it's nice. And there's very good mathematicians there. Maybe less so now than it was before. Right. So this doesn't necessarily mean something. So I guess the strongest thing is being asymptotically stable, I would say. I mean, being stable is like, it may be that the solution never really reaches the point, but having it asymptotically stable means that it will always reach, given that the initial point is close enough to the equilibrium point. X will eventually reach the equilibrium point. By being stable that's not necessarily the case. And being unstable means that we cannot really control how close it is to the equilibrium point. That makes sense. Also great competitive programmers. Alright, I didn't know that. I mean, I would. Why not? Right? Yeah. Hello, Patnaik and CubeRequest. How are you doing, CubeRequest? I feel like it's been a while since the last time I saw you. Anyways, let's see. Okay, we've been going for 6 hours and 10 minutes. Alright, so these are different cases. So we are assuming that we have a linear system, and we're trying to, and we've restricted to like a real 2x2 matrix. And it's also with constant coefficients. It's not dependent on t. And then depending on if it has two separate eigenvalues, if both of them are, so if both of them are negative, if both of them are positive, or if they have opposite signs, we get a stable knot, a saddle point, or an unstable knot. And in the other case where they have a single eigenvalue, but that they are not necessarily, and we also assume that A has a non-zero eigenvalues. but we can still have eigenvalues that are the same, which is fair. And then the general solution will be ETA, which is equal to E lambda Ti. Right, so we can write it like this, I guess. Wait, is that true? And the general solution of the system is this. Is it mostly self-study or teacher teaches most math? I mean, here I think it's a very, very good system. It's mostly like, I know some universities have like mandatory, like you need to go to lectures and you need to go to seminars, and if you don't, you'll get like, they'll like expel you or something. Maybe not expel, but you need to have attendance at least. And in some courses this is true, or in some cases, like when doing labs and stuff, if you're doing physics. But here in mathematics, you never really need to go. You have no like mandatory lectures or mandatory seminars. So in that sense, it is very independent. But at the same time, like, you have lectures. I have a lot of lectures every day, or like every week, you know. And every day I have at least a seminar or lecture. 75% attendance, that should be removed. Yeah, there is like no attendance. You don't need to do. In theory, you don't have to go to any lecture. You can just go to exam, which I like. I mean, it makes it more independent, and that's good, I think. If you don't feel like you need to go, like, you don't need to go. But of course, in general, you should go to every lecture and seminar. It's good. It's good. Okay. Unstable improper knot. Has non-real conjugate eigenvalues. Is a linear combination of these. After the introduction of a phase angle delta, we may write, if sigma is 0, the orbits are ellipses around the origin. The origin is a stable but not asymptotically stable equilibrium point. Is it stable? I don't think it's stable. Oh yeah, it is stable. Yeah, it is stable. Because if epsilon is, for any epsilon, we can always pick the initial point to be close, and since it's just a circle, that's closed, we can always have it inside some ball. It's called center. Inwards or outwards. If U, W are negatively oriented, the figures should be reversed. In the classification 1 to 3 above, knot, saddle, and spiral are the typical cases. As the terminology indicates, 2 may be considered a degenerate case. An arbitrarily small change of the coefficients in the matrix A may turn an improper knot into either a knot in 1 or a spiral in 3. In the same way, an arbitrarily small perturbation of a center will change it into a stable or unstable spiral. Right, so we can have the knot case, like everything goes like this, and then it was like the star case, and then the spiral case. General, okay. Near an equilibrium point, assume that f is continuously differentiable in a neighborhood of the equilibrium point with Taylor expansion, blah blah blah, where the limit as x goes to this. What is r of x? Oh, we have r. Oh, is the remainder. Yeah, so the remainder goes to 0. Here f of this is 0. If we neglect the remainder term, we obtain an approximating linear system with this variable. We call it linear system. The linearization of the system at point x hat. Cannot find the book. May be exclusive only for Lund Uni students. I mean, the people who wrote the book, I'm not really sure what uni they're from. I think maybe Stockholm. Maybe. Or maybe they're from Lund actually. Because I've many of the books are from Karl, Gustav, Andersson. Yeah, I think he's from Lund actually, but I'm not sure if he works there anymore. Haven't seen him, at least. From the linear system, you may obtain information about the behavior of the solution of the original system near this. Assume, for instance, that A has no eigenvalue on the imaginary axis. Then one can show that there is a continuous function with a continuous inverse such that this is true, and that y of t is h of x of t is a solution of the system for every solution. We do not need to prove this theorem. However, we will see in section 5.4 prove that if all eigenvalues of A have a strictly negative real part, then x hat is asymptotically stable, and if some eigenvalues of A has a strictly positive real part, then x of hat is unstable. Okay. Well, this is like a rough read through. I'll spend tomorrow, or maybe at least I'm not sure if it will be exactly tomorrow, but some other time going through the thing, you know, like the exercises, and then tomorrow during lecture it'll be about 5.3 onwards. But I feel I got a good like idea of what we're actually doing. I mean, it's quite nice that for any general one we can use what we learned for the linear case, especially in like a neighborhood around the equilibrium point, to see if it's asymptotically stable or just stable or unstable. But when it comes to actually calculating, I don't really know what I'm doing. But anyways, I think I'll just end the stream here. It was a nice 6 hours, but at the same time not really, because I was stuck like crazy. But that's fine. I'll try not to get discouraged. Some days I guess are just like that, and hopefully tomorrow will be a bit better. I know some streams are very nice. You just like, you look like a genius. You just flows like water. But here I was like struggling all the time. But yeah, I mean, I remember a quote. It's really not that deep, but at the same time it's nice. I think it was like, I mean, to become smart or knowledgeable, you have to experience being dumb and like not knowing what you're doing. So it's at the same time like it's part of the process, and eventually it will stick. Anyways, tomorrow I'll stream probably in the afternoon. I have some things in the morning, stats lecture, and also I'll have a driving license like practice, and then I'll just start in the afternoon at around maybe 7 or something p.m. in my time, which is plus, I think summertime has ended, or maybe it will be ending at the end of the month. So it's either, I think it's now +2 UCT, UST, Universal Standard Time. So if you want to sync up. Not knowing is a precursor for learning, otherwise you won't be learning. Exactly. That's a good way of writing it. Yeah, I mean, if you're not struggling, you're not learning anything. So it's good to struggle. How hard from 1 to 10 is a bachelor in math at Lund Uni? For me, I would say it's very difficult. I mean, compared to physics, I did physics, and physics is difficult, but it's fine. For me, it was at the beginning, it was really difficult, and but it was also really fun. I really enjoyed this, and yeah. I also did it like, I made it difficult for myself since I studied at 150% and also 200% the last semester of my first year. So I had like double the workload as everyone else, since I was doing like a double bachelor basically, or at least I was following the physics and the math program since I wanted to switch. So yeah, but in general I would say it's kind of difficult. I'm not gonna sugarcoat it, but I think it's possible for everyone if you have enough dedication and stuff. It's mathematics is certainly not like any more difficult than being able to draw really well. I like comparing it to drawing, since I was once an artist, and I still consider myself like a part-time artist. There is no magic math, essentially. When it comes to learning, at least, you have to do the same thing as if you want to learn anything else. Anyways, I won't be I feel like a motivational speaker now. I'll just end it here, and I'll see you guys tomorrow. I'll basically just go to bed, and